Hello all, my name is Krish Naik and welcome to my YouTube channel. So guys, we are going to continue our LangChain series. Till now, we have seen a lot of end-to-end RAG and document Q&A projects with different vector databases like FIS, like Chroma, like DataStax, AstraDB, and many more. But today in this particular video, I'm going to probably develop a complete amazing document Q&A end-to-end application, generative AI application, with the help of this amazing vector database, which is called as ObjectBox. Now, why this specific database I'm actually using, I'll be talking about this entire features, like why it is specifically useful and how it can be definitely advantages when compared to the other vector databases that are available in the market. Regarding this ObjectBox, as I said, this is a completely open source. You can also definitely use it out. I will be going through it and I'll also be showing the GitHub page with respect to this particular database itself. And one more amazing thing is that it has integration with multiple coding programming languages. That also I'll probably show you. So what exactly is ObjectBox? You can see over here some brief description over here. You can see any app is only as good as its data. The on-device object database ensures data is smoothly available when and where needed. No internet, no cloud. So this is the main feature over there. ObjectBox brings high performance and resource efficiency to devices at the edge of the network, like mobile phones, IoT gadgets, industrial machines, and medical equipments, microcontrollers, and all the smart things around you. So over here, you don't need to basically have any cloud or internet platform or any kind of internet also to probably access this. It provides you amazing resource efficiency to devices, specifically if you're using in mobile, IoT, industrial gadgets, and machines, right? So here you can see ObjectBox powers solutions across industries. Many companies are specifically using it. Some of the important features are that it is high performance, like ObjectBox is 10 times faster than the alternatives with high speed data ingestion that increases the response time. From sensors to server, you will be able to use it in, and it is supported in Linux, Windows, Mac, Android, Raspbian, probably each and every operating system out there. So if I talk about IoT devices, edge devices, everywhere it will be supported. Sync data seamlessly. ObjectBox out of the box synchronization makes data available when needed, eliminating data islands and improving data flow. Offline first, develop application that works on and offline independently from a constant internet connection, provides an always on feeling. So this is one of the most important feature which I have probably not seen in any other vector databases. Then over here you also have something called as go faster to market, reduce cost, reduces mobile network and cloud cost more than 40% by persisting data locally on the edge, right? So it will be able to efficiently store the data within the local itself in a way, and we'll also be able to see all the files that is probably created. I will show you completely when we go ahead and implement this end-to-end solution. Okay. Now, if you also make sure that you go ahead and visit this GitHub page, make sure that you do the star mark over here, because this is an amazing open source work and it has been supported by multiple programming languages now, like Java, Go, Swift, Dart, C, and it also has support for Python programming language. Over here you can see Python programming language and many more. So in short, this is a super database altogether. Now let's go ahead and show you this specific feature. And here I'm going to create an amazing end-to-end document Q&A. Completely it will be end-to-end, and we will try to show you the entire demo. I'll try to show you the entire demo with its entire working. So let me quickly go ahead and open my file. So here is my the same project that I've been working in LangChain, because I really want all the materials to be one side. So here you can see I've created already an ObjectBox, and there is a folder which is having PDF file. So as you know that I'm going to create an advanced document Q&A along with sessions, along with this vector database that is called as ObjectBox. So quickly, let me go ahead and create my file. Here I'm going to go ahead and write app.py. Okay, app.py, I will just make sure that I put it over here in the outside folder. I don't want to put it in the inside this US Census folder. So US Census is basically having all the documents which I'm probably going to ingest. Okay, so all those things I will try to show it to you. And one more very important thing over here is that till this process is probably taking place, let me just go ahead and show you one more thing. Here is my command prompt. I'm going to install one very important library which is specifically required for this particular object box. Over here, you'll be able to see that. Just go to the specific environment that you are actually working in. And then we will go ahead and import the library that is required for the object box. Okay, so the first step over here, let me quickly go ahead and write, is nothing but pip install, okay, LangChain, because it also has now LangChain integration support. So here you can see, I'm going to just go ahead and write LangChain object box. So if we go ahead and write this, here you'll be able to see this. Pip install LangChain object box, and once I press enter, you'll be able to see that the entire installation will take place. Okay, so we'll wait till the installation is probably taking place over here, and once the installation is taken place, we will be able to work along with LangChain too. Okay, so here I'm going to use multiple things. I'm going to use Grok APIs for using the open source models. Along with that, I'll be using OpenAI embeddings, because my embeddings, I really want to make it very much quicker. Okay, and it'll be a complete end-to-end project as we go ahead. Now let us go ahead and start writing my code. Initially, as you all know, for this, I will be importing some of the important libraries. So I'm just going to paste it over here. So here you see that I'm importing something called a Streamlit. Okay, so I'm just going to save this. So we will be using Streamlit library. I'm using import OS. Since I said that already, we are going to go ahead with Grok. Okay, so Grok is the library that we are specifically going to use over here because we need to interact with the open source Llama LLM models. Specifically, I'll be using Llama 2 or Llama 3. Then you can see that I have actually imported LangChain underscore OpenAI. I have imported OpenAI embeddings. Okay, and let me close this till the installation will probably take place. Then we have LangChain.TextSplitter. I'm going to use recursive character text splitter for dividing my entire documents into chunks. Then you will be able to see that I'm using combined documents to create this create stuff document chain. Then I have my chat prop template so that I can create my own custom prompt. Along with this, you'll be able to see I'm also importing create retrieval chain. Okay, so all these things are there. Now the other thing that I really want to go ahead and do it is nothing but LangChain underscore object box. As you all know that I have already imported this object box dot vector stores. Okay, vector stores. Okay, so vector stores, and here I'm going to import object box. Okay, so these all libraries are there. Let me just save it. Let me open my terminal and see whether everything is working fine or not. So quickly here I will just go ahead and write Python app.py. Okay, so I'm inside my object box folder. So let's see whether everything will get executed perfectly fine or not. Okay, so once this gets executed, that basically means all my import statements are working absolutely fine. So yes, I feel that it is working fine. Now let's go to the next step over here. Now once we have imported all these libraries that I specifically require, then I will go ahead and write from LangChain underscore community dot document underscore loaders. And since I really need to read all this particular PDF from my US census folder, so for this I will be using a PyPDF directory, and again it is a part of LangChain itself for the data ingestion process. Okay, so all this libraries has been imported. Now the next step is that we will go ahead and call our APIs. Two APIs we specifically require. One is the OpenAI API key and the Grok API key. If you're following the series of my videos already, I think you'll be able to understand. For Grok, what you can do is that just go to the Grok website, so grok.com. Okay, and if you don't know this about Grok, it is basically, it provides you a LPU engine and along with the access with respect to all the open source LLM models. So here you can see that you have Gamma 7B models, Llama 3, 8 billion parameters, and along with Mistral, right? You can go to, just click over here on Grok Cloud. Okay, so here you can just click on Grok Cloud, and with respect to this, you just go to the API keys and you can probably create your API key. And this is the API key that I will be using in my project. Okay, so I have repeated this many number of times in my previous video. Now let me just go ahead and write from .env import load underscore .env. Okay, and the reason is that because I have actually created in my environment variables. So this is my environment variable where I've created all the keys. So to load all the environment variables, I will specifically be using this. Now I'll go ahead and write load the grok and OpenAI API key. Okay, and here I'm just going to write os.environment. Okay, and I will go ahead and write open underscore API underscore key, and I'm just going to call my open API key. The reason why I'm calling this is that because I'll be using OpenAI embedding. Now see, I can also use Ollama embedding if you want, but again, I want this embeddings to happen quickly and the accuracy should be very, very high, right? So this is what is my environment variable that I've actually created over there. Okay, so all the things are there over here. So let me just go ahead and start writing our further code. Now I have actually imported the OpenAI API key. The next key that I'm actually going to use is my grok underscore API underscore key. And this again, I'll be using os.getEnv. And here, let me just go ahead and write this grok underscore API underscore key. Understand, these all keys are necessary to load my Llama 3 model. Okay. Now the next thing is that I will just go ahead and write my st.title. I'm saying that ObjectBox vector DB vector store DB with Llama 3 demo. Okay, so let me just go ahead and create my LLM model. Okay, so this will basically be not but chat grok I'll be using. Here I'm going to use my grok API key itself. So let me just go ahead and create my grok API key. And the second thing that I will be using is my model underscore name. The model name that I'm going to use for this is my Llama 3 8 billion parameter, and the code is 8192. Where did I get this from? I have actually seen the documentation. If you probably see over here in the grok, this is what is the model that I've actually specifically used. Okay, so here this will basically be my LLM model that I'm actually going to use. Okay, the next thing, okay, this should be my variable LLM. Okay, the next thing what I'm actually going to do is that I'm going to create my prompt, and this will basically be my chat prompt template. Okay, and along with this dot from underscore template. Okay, okay, and here I'm going to basically go ahead and write my prompt. Okay, now a generic prompt that I'm going to give over here is this one. Okay, a generic prompt for any kind of context. Just a second, I will just press tab. Okay, so I'm saying that answer the question based on the provided context only. Please provide the most accurate response based on the question. This will be the context. Now whenever we are using context, two things are definitely required, and over here we have specifically imported. One is the create stuff document chain and create retrieval chain. This create stuff document chain will be responsible in providing the remaining context that is required over here, along with the input that we are passing. Okay, and along with that, create retrieval chain will actually help us to invoke the entire LLM chain, which we are specifically creating. Okay, so this basically becomes my chat prompt template. Now it's time that we should go ahead and start with our vector embedding. Okay, so vector embedding and storing and ObjectBox vector store DB, right? So this is what we are basically going to do over here, and understand this is the most important thing. Here we will be able to see that how we can actually save this in our locally, the entire vector store database, that is ObjectBox. So I'll create a function and I'll say this will basically be my vector embedding. And with respect to this particular vector embedding, now see, the thing is that whatever vector I'm actually going to create over here, or vector database that I'm going to create, I'm going to make sure that it is an ObjectBox vector database. Along with that, what I will try to do is that I will also save that in sessions. So Streamlit usually provides the entire sessions itself. So here I will go ahead and write if vectors not in st.session_state. So here we are going to basically go ahead and write st.session_state dot embeddings. So the first embeddings that we are basically going to create, and this is nothing but this is my OpenAI embeddings. Okay, now you know that I have to read all my PDFs from this particular folder, right? So for that, I will be using a data ingestion technique. Already you know that we have imported py-pdf directory loader. So I'm just going to write st.session_state.loader, and this will basically be equal to py-pdf directory loader. And along with this, I will go ahead and write .us_census. Okay. And here you're going to specifically use data ingestion. Okay, so this basically becomes my data ingestion over here. And now let me just go ahead and create my st.session_state.docs. Okay, and this will basically be equal to st.session. So see, the thing is that I'm creating my document. So this loader, okay, this loader will be, okay, just a second. Okay, this loader will be loading all the PDFs from this particular folder, and it will be saving it in this particular variable, which is called as loader. And this st.session state, what we are doing is that we're creating the session variables, right? So that we can use it anywhere. Now this documents will specifically have over here, you can see that when we write st.session_state, okay, dot the loader that we have actually used, and we'll just go ahead and load all the documents. Okay, so once we load the documents, so here I'm just going to give a comment saying that, hey, we are loading all the documents. So documents loading, right? Now, once this is done, what we are going to do is that I'm going to probably create my session_state.final_documents. Okay, and this will basically be equal to session_state.textSplitter. So once we take this entire documents, okay, then what we need to do is that we need to probably divide this into chunks. Now, in order to divide this into chunks, obviously, I also have to load. So here I'll be basically writing st.session_state. Session_state. And here I'm basically going to create a variable which is called as TextSplitter, because I need to divide all my documents into chunks, right? So here I'm going to use recursive character TextSplitter, and here the chunk size will be nothing but it'll be 1000, and chunk overlap will be nothing but 200. Okay, so I'm just keeping this particular feature. Now understand why we are doing this. We are since we need to, whatever documents we are actually getting, we really need to divide this into chunks, right? And there will be multiple documents in short. So all the final documents that we are going to get, I'm going to use this text_splitter. So here we are going to write text_splitter, and here we'll use a function which is called as split documents. Now understand one thing, inside this split documents, you know that we have to provide all our documents. So I'm just going to copy this, paste it over here. Okay, and let's say I give my first 20 documents because I want to quickly finish this application, so that at least when I'm running it in my local, it does not take time in order to convert the vectors. See, at the end of the day, you can put any size of the documents that you really have. Now, once we do this, then the next step is that st.session_state.vectors. I'm going to basically use my object box. Okay, there's one spelling mistake. Okay, st.session_state. Here I'm going to specifically call my object box, which will be responsible in converting all the documents, the final documents, into vector and store it in a vector database. And that is nothing but object box vector database. So here I'm going to basically go ahead and write from_documents. Okay, and here we are going to give st.session_state st.session_state and call my final documents. So this will basically be my final documents. Along with this, I can actually use my embeddings, and now embeddings is nothing but the same embeddings that I have, right? So I'll just copy and paste it over here. So in short, at the end of the day, after doing all these particular steps, you'll be able to see that I will be able to convert into vector embeddings, and it will be storing it in the object box vector database. But one more parameter I will be giving over here is nothing but embedding_dimensions, because we can also set our dimension. And let's say that I want to probably set my dimensions to a parameter let's say embedding dimensions, we can set it to 768. Okay. And this is what we are basically doing. At the end of the day, after executing this particular code, this vectors variable that is probably saved in the session is nothing but it is a ObjectBox vector database. Okay. So all these things is specifically done. So this method is going to probably perform all these things, and it is going to save the vector database in our session state variable. Okay. Now let's go to the next step. Here I'm going to define my input prompt. So this will basically be my input prompt, so that I will be able to ask any question on this particular input prompt. And let's say over here I use a text input box. Okay. Now one thing you should be noting over here is that I will also create a button. Okay. And this button will be nothing but my document embedding button, right? Now this button, as soon as I click this particular button, what it should do is that it should hit this particular function, and it should load all the PDFs from this particular folder, perform, basically load it, convert all the documents into chunks, then split that particular documents based on this particular chunks, and then finally convert it into a vector embedding and store it in a vector database, right? That is nothing but ObjectBox vector database. So here you'll be able to see that I will go ahead and call this particular function, which is nothing but vector embedding. Okay. And in the next line, I will go ahead and write ht.write. And here I will say ObjectBox vector DB or ObjectBox database is ready. Okay. So ObjectBox database is ready. Okay. And right now it will be storing in my local folder itself in a much more efficient way. And we'll also be able to see that. Okay. Now let me quickly go ahead and import time, because I also need to check how the time is with respect to how much time it is probably taking up. So if I say if input underscore prompt, whenever I give my input prompt and press enter, then now the first step is that obviously you know that my vector store is ready. My vectors is ready over here, right? Now, in order to call it, as I said you, right, since the kind of prompt that we have used, we really need to give context over here. Now, in order to get the context, we will be using the document chain. So here I'm going to basically go ahead and write document underscore chain is nothing but create stuff document chain. And I already have taken all these things in my LLM series, right? My LangChain series. Here it will require two parameters. One is the LLM and one is the prompt. Understand from this, we will be able to get the relevant context information. And after this, creating this document chain, whatever vector database we have, right? So here I'll just go ahead and call my vector database. It is nothing but st.session underscore state dot vectors. And here we are just going to dot vectors. We are just going to use as retriever function. The reason we are specifically using this as a retriever function, it is very simple, because if I really want to convert this vector database and I want to retrieve results from it, by using this as retriever, it will create an interface on top of this particular vector DB. Okay. So finally, I'll be able to retrieve any information from this whenever I do any kind of search. Okay. Now this is done. Now the next step, what I can actually do after this is that I will also go ahead and create my retrieval chain. Okay. So here, let me just go ahead and create retrieval chain. And here I'm going to specifically use my retriever along with my document chain. Okay. So in short, I'm also using this with my LLM model. Okay. And finally, you'll be able to see that I will be creating my retrieval underscore chain, which will be nothing but this. Now, the final thing is that after all this particular process is done, we just need to invoke this retrieval chain. So I'm starting my timer over here. I will give my input. Okay. So let's go ahead and call this. So here I'm going to basically write response is equal to retrieval chain dot invoke. Okay. And with respect to this, let me just give two parameters. One is my input. Whatever input we are specifically giving, that will be basically in my input prompt. So this input prompt I will be giving over here. So this will basically be my input. I will get the response, and let me record the response time and display that results over here. Okay. So finally I'll be able to see my response time. So in short, see what is happening. This vector is basically an ObjectBox vector database. Okay. We are probably creating a retrieval on top of it. And finally we are creating a chain, and we are getting the response by invoking this particular chain, right? And finally, we can also display some of the metadata information. So here I'm just going to write this code with st.expander, document similarity search, response context. I'll also be able to display the context over here. So almost everything is done over here. I think we are good to go. We are good to run. Right now, you'll be able to see that I don't have any folder regarding ObjectBox, okay, the vector database that we have created. But as soon as I run this, so I will go ahead and open my terminal. Okay, so this will basically be my command prompt. So in order to run it, I will go ahead and write streamlit run streamlit run app.py. Okay, as soon as I execute this, you will be able to see that yes, my local host will get opened, and now here you'll be able to see the entire demo. Okay, let's see the entire demo. So ObjectBox vector store with llama 3 demo. So first of all, I'll click on document embedding so that it will probably read all the document files from the folder, and then it is going to probably perform the embedding. So here you can see one error is there, chunk size. Okay, let's go ahead and create this chunk size also. Chunk size, I think I've made the spelling mistake over here. Okay, where is the chunk size? Chunk. Okay, this is my chunk size. Okay, no worries. Now I will just go ahead and let's say always run. Okay, and let's go ahead and click on document embedding. Let me go back to my file. So here you'll be able to see one folder will get created automatically, right? And that folder is nothing but my vector database, that is ObjectBox vector database. So sometime, let's see whether any error has come. Okay, again a spelling mistake. So similar kind of mistakes will be there. So don't worry about it. Things happens. So you don't have to see over here, final documents. This is ObjectBox has no attribute from documents. So here, documents, okay. Now I think it should be working fine. Okay, I will go ahead and click on this. Now I think it should run. It should run. Yeah, it should run. Okay. Yes. Now you can see the folder is there. MDB file is there with respect to this. Log.mdb file is also there. This is my entire data with respect to the vector database that I have. Now it's time that I can probably check what information I have to type and search from this particular documents. So let me just open this folder. So I will go ahead and reveal this particular folder. US sensors. Let me open this first folder itself. Okay. So here you have this. Okay. So I will search for anything as such. What is the difference? Some question. It's up to you what question you really want to ask. What is the difference in the uninsured rate by state in 2022? Okay, again I've clicked on document embedding. I don't know why, but again I pressed enter. So here you can see what is the difference in the uninsured state by in 2022. So here you can see I'm getting all the response. According to the provided context, the answer is the unreturned decreased across 27 states, while only Maine had an increase. Maine had an increase from 5.72. So I am able to get all the response properly. Let's search for some more thing. What is the private health insurance cover by state in 2022? So let's go ahead and check it out with respect to this. I will just copy and paste it, press enter. Automatically, as soon as I press enter, you'll be able to see how quickly this is. And this is also because of Grok inferencing engine. And the best thing is that from the document embedding, how quickly you're able to get it, right? The ObjectBox vector database performs so exceptionally well within the local, right? And it is created in such a way that you can probably use it in mobile devices, edge devices, and many more things, right? You can probably see the documentation. It supports multiple languages, Java, Python, Kotlin, many more, right? And here also you can probably see the document similarity search is also coming up. According to the provided context, the private health insurance state refers to the percentage of individuals in each state who had the private health insurance coverage. So all this information is also coming with respect to the context. So great. I hope you like this particular video. This was why so powerful this ObjectBox is. I would suggest if you're probably working in any companies, you should definitely look at it. Please make sure that you fork and march, keep a starred option over here. So any new updates that will probably be coming up, you should be able to see it over here. And that is what we should look at, what are the better ways to specifically create some amazing end-to-end projects. So yes, this was it from my side. I'll see you in the next video. Have a great day. Thank you and all. Take care. Bye-bye.